This figure is a square with a triangle in it. If the sides of the triangle are 3, 4, and 5 units, and x is the length of the triangle, find the length of x. To solve this problem, let's label the vertices of the square as A, B, C, and D. And this point, E, and F. Next, let's take note of some details in the figure. Since the figure is a square, the angle in each corner is a right angle, that is 90 degrees. And all the sides of the square are equal. Also, let's remember that a 3, 4, and 5 triangle is a right triangle. That is, the angle between the side of 3 and 4 is 90 degrees. Next, let's consider triangle AEF and triangle CDE. In these triangles, angle EDC is 90 degrees, likewise angle EAF. This shows that both triangles are right triangles. In triangle CDE, if we call angle ECD Y, it follows that angle DEC will be equal to 90 degrees minus Y. And the reason is, sum of angles in a triangle. In triangle AEF, angle AEF is Y. Reason: the sum of angles in a straight line. That is 180 degrees minus 90 degrees minus 90 degrees minus Y. 180 minus 90 is 90. So, we have 90 minus Y, which will give us 90 minus 90, plus Y. 90 will minus 90, and we are left with Y. And angle AFE is 90 minus Y. Reason: the sum of angles in a triangle is 180 degrees. From both triangles, we can see that angle EDC is equal to angle EAF, that is, 90 degrees. Angle ECD is equal to angle AEF, that is, Y. And angle DEC is equal to angle AFE, that is, 90 minus Y. Hence, we can say that triangle AEF and triangle CDE are similar triangles. That is, both triangles are proportional triangles. With this side proportional to this side proportional to this side, and this side proportional to this side. Since these triangles are proportional, they have the same ratios. If that is the case, we can say that AE over DC is equal to EF over EC, and EF over EC is equal to AF over ED. Going further, we are going to focus on AE over DC is equal to EF over EC. Since the length of the square is x, if we call ED Z, then AE will be x minus z. From the figure, EF is 3, EC is 4, and DC is x. If we go ahead and plug in these values in the above equation, we will have x minus z over x is equal to 3 over 4. Next, we cross multiply, and this will give us 4 times x minus z is equal to 3x. 4 times x is 4x, 4 times z is 4z. So we have 4x minus 4z is equal to 3x. Collecting like terms will leave us with 4x minus 3x is equal to 4z. 4x minus 3x is x. So, x is equal to 4z. Dividing through by 4 will give us z is equal to x over 4. Next, we are going to find x in triangle CDE using Pythagoras Theorem. From Pythagoras Theorem, For squared is equal to x squared plus x over 4 squared. For squared is 16, so we have 16 is equal to x squared plus x squared over 16. Next, we simplify the terms on the right side. To do so, we take the common denominator. The common denominator is 16. 1 into 16 is 16. 16 times x squared is 16x squared. 16 into 16 is 1, 1 times x squared is x squared. So, we have 16 is equal to 17x squared over 16. By cross multiplication, we will have 256 is equal to 17x squared. Dividing both sides by 17 will give us x squared is equal to 256 over 17. Next we find x by taking the square root of both sides, which will give us x is equal to the square root of 256 over 17, which is the same as x is equal to 16 over root 17. Thanks for watching. If you liked this video, make sure to subscribe for more.